Okay, so this is the first video to do with Lecture 4 on moments, specifically looking at the introduction to moments. So you may be familiar that a moment, as you'll have done them, about a point, we'll call it O, is equal to a force times a distance. And that would be a perpendicular distance. So for example, you might have done something previously where you've got force acting downwards, got a distance from a point, and we'll call this point O. There's your force, there's your distance, and your moment would be your force times your distance. The key point there is they're at 90 degrees to each other, so it's a perpendicular distance. Sometimes that's called a torque. What we'll look at now is looking at things where we've got vector components rather than scalar components. So we'll look at both methods of solving these. One thing to look at if we're just dealing with pure scalar, so as we have here, is if we had a more challenging question. So for example, you had a point here, point O, and you had your force acting in that direction. There are two different ways of solving this. You could either multiply, if you had the information, multiply the force by that distance there, which would be the perpendicular distance from point O, or you could look at it in a slightly different way, which I'll just draw. If you had, this is very similar to slide 7 in the lecture. If you had your force acting there, and you've got a distance here, which we'll call A. Why are we calling that A? Let's call that X, and that Y. Then, if you don't know the distance to O, apologies, the distance to O, as in the distance perpendicularly, that distance there, then what you can do is you can use resolving your forces as we were in previous lectures. So we can resolve into Fy and Fx, and then our moment about point O becomes our force Y times by our distance X plus our force X times by our distance Y, because they come in pairs. So you've got Fy and X are perpendicular, Fx and Y, if you imagine your Y down there, would be perpendicular. One thing we haven't said is that you often treat forces, we've talked about upwards for the Y direction, for instance, here being positive and downwards being negative, to the right for the X being positive and to the left being negative. What we do with moments is we call normally anti-clockwise positive and clockwise negative. So if you imagine force Y in this example, the force in the Y direction would be trying to turn that lever, and it'd be trying to turn it anti-clockwise. So it would be working that way. Force X would also be trying to turn it anti-clockwise. So these are both positive. If one component was trying to turn it the opposite direction, hang on, sorry, that's wrong. My mistake, apologies. I'll leave it in so it proves I do make mistakes. Force X, if you ignore everything else that's happening, just this force X is trying to turn the beam, if you like, it's trying to have a turning effect going clockwise. So rather than having a positive sign here, we've said anti-clockwise is positive, so we know that for this equation that will need to be negative. Okay, so Normally, there is one example in the lecture where this doesn't follow, but I'll try and point it out when I spot it. Anti-clockwise is positive, clockwise is negative. So here it's not the direction of the forces. When you're doing the sum of the moments, it's the direction of the turning effect that results that defines the signs. So that was your introduction to moments. We'll go on in the next video to look at looking at some things to do with vectors and cross products.